Okay, the next thing that we're going to talk about with polynomials is something called power functions. And power functions are where you're just looking at one term of the polynomial. So we have something like a x to the n. We're actually just going to look at the x to the n part for now, just to keep things simple. There's two different cases for power functions. One is where n is even, and one is where n is odd. So first we're going to look at n as even, and we're going to look at things like x squared, x to the fourth, x to the sixth, and so on. So we've got an even exponent. So let's look at a graphing utility and see how these behave. So here's my online graphing utility, and there's x squared, which we know. We've looked at that quite a bit. So what happens if we do x to the fourth? Okay, so the line that just came in is x to the fourth, and that's this one. Okay, so what's happening here is that between 0 and 1, when you raise numbers to higher exponents, they actually get smaller. Numbers between 0 and 1 actually get smaller. So that's why you're seeing it flatten out right here. And then after 1, when you raise it to a bigger exponent, it gets bigger. So that's why we're seeing this looking a little bit flatter through here and steeper on the sides. Then if we put in x to the sixth, what happens there? Well, it got even steeper. Okay, we got even more flat across here. It looks flat, but it's not. Okay, if we zoomed in, you would see there's still a curve to it. It looks flat through the middle and steeper on the sides. And let's look at what happens with x to the eighth. Okay, even steeper. So the sides get steeper and steeper. The bottom gets flatter and flatter. It starts to look more like a cup, but in general, it's still got that same U shape. All right, so let's go back over here. So when we're looking at x squared, x to the fourth, x to the sixth, remember that they're going to look a lot like x squared. Okay, the higher the exponent, the more it's going to flatten out in the middle, but it's still going to be that U shape. So if we're looking at variations on this, let's say we have like x plus 1 to the fourth. We want to know what this looks like. Well, we know that x to the fourth is U-shaped, and we know what plus 1 inside the function does to the graph. So remember, if we add or subtract a number inside, that's going left or right, to shift left or right, and it's opposite what you'd expect. So this is going to shift us left 1, and the exponent of fourth is going to be U-shaped. Okay, so we should be able to sketch this without plotting any points. We're going to go left 1, and we're going to be U-shaped, just a little bit steeper than a typical parabola. All right, let's say we have y is equal to x to the sixth plus 3. X to the sixth, you think, okay, x to the sixth, I know that that is U-shaped. It's just going to be a little steeper. And what does the plus 3 do? The plus 3 is outside the function, so that's a shift up or down. So plus 3 is going to take us up 3. So we go 1, 2, 3. We're going to be U-shaped. We're going to be pretty flat through the middle here because it's to the sixth. So we just draw it a little bit flatter and steeper. Okay, and that's what we look like. So now we know how to draw some polynomials because we know what x squared looks like. Okay, so let's look at the other case where n is odd. Okay, so now what happens if n is odd? So we end up with things like x, x cubed, x to the fifth, x to the seventh, and so on. So what are those going to look like? Let's go back to our picture. Give me a second to delete these out. These were all of our even ones. Okay, so x, we know what that looks like. That's a line. Okay, there's our line. We also know what x cubed looks like. That was part of one of our function sets. That looks like that. Okay, so the line is called a degenerate case. It really doesn't do much, so we kind of ignore that one. We look at x cubed. We look at x to the fifth. Okay, here, let me take the line out because that's blurring things a little bit. All right, let's look at x cubed and x to the fifth. All right, if I take out x to the fifth again, there's x cubed. Now look at what happens when I put in x to the fifth. It's almost the same picture, almost the same picture. Again, between 0 and 1, we flatten out. And again, after 1, we get steeper and steeper. Okay, so we can see here in the middle, we're going to flatten out, and on the sides, we're going to get steeper and steeper. And then x to the 7th flattens out even more, and the sides get steeper and steeper. Okay, so they pretty much all look like x cubed. I can also show you x to the 9th. You're not going to see a whole lot of difference there. Okay, so more flat and more steep. So they all pretty much look like x cubed with the exception of x. It's got no bend to it at all, but you guys already know what that one looks like. So all of the other odd functions are going to look like x cubed. They're going to get flatter through the middle the higher the exponent is. Okay, so let's go back to here. So if n is odd, we know that these are going to look like x cubed. It gets flatter in the middle and steeper on the side. So again, we can draw some of these. We could have x to the 7th. Let's say x to the 7th minus 2. And you say, okay, x to the 7th, I know that looks like x cubed. And the minus 2 is on the outside, so that's going to shift us down 2. Okay, so we look like x cubed, shifted down 2. And when we draw it, we're going to draw it a little bit flatter and a little bit steeper than we would for x cubed. All right, let's say we have y is equal to x minus 3 to the 5th. X minus 3 to the 5th. So you see that exponent of 5, you think, okay, it looks like x cubed. The minus 3 is on the inside. Inside is left and right, and it's opposite what you'd expect, so that takes us right 3. So we're going to go to the right by 3, 1, 2, 3, and we're going to draw in something that kind of looks like x cubed. Okay, so that tells us what power functions look like.